Welcome back, and we are going to start with the four-step method in this video. So this is essential in everything that we do in statistics, and so you're going to use it so often that you're going to get blue in the face and you're going to hear it and be like, oh my God, we have to do a ton of writing, and well, yes, and yes, you still have to do it, but the idea is that anything in statistics you can break down into this kind of four-step method, and it in a way it sort of mirrors the scientific method, but the four steps that we're going to follow are state, plan, solve, and conclude. Okay, and you can see here are kind of the expectations for each of the components. So in state, you're going to, guess what? State the problem. Okay, so really just, what is the goal? What is the question that you're responding to? In plan, guess what? You state the plan. So you state the tools, methods that you're going to use to respond to the question. Other things that you really should do is identify any assumptions you're making, as well as variables and their types, just to make sure that you're doing everything correctly. With the assumptions, you really should check to make sure that they're satisfied. So for us in our context, right now we have a very limited toolkit, so most of the things that we're going to do, you don't need to check the assumptions. Okay. Later on, though, super important. Number 3, you're going to solve it, so do it. And then conclude, respond in context, and then state the evidence gathered, and then also if there are any sources of error, like eventually we're going to be, rejecting or failing to reject the null, and then you have to say, oh, we could be making a type 1 or 2 error down the road. Okay, but for now, you can just kind of mention like, oh, there might be error in the reporting or something a little vague. But for this, we're going to do this as an example. So 2.2 in Excel. So you might need to open up that file. I have it open here. So here we are looking at a lot of interesting things, and then I'm just like, okay, what am I answering? Oh, okay, so it's this question. Do the state birth rates for women ages 15 to 17 seem to be significantly different between 1990 and 2016? Well, okay. So, yep, they're all like there's 1990 birth rates and then 2016 birth rates. Okay, so and then it says include descriptive statistics, blah, blah, blah. Okay, so to begin, I'm just going to start typing here. So there's going to be state. I'm going to outline this. Plan, solve, and conclude. Also, I'm going to be typing fast. So if I make errors, you got the idea. Okay, so state. I need to state the question that I need to solve, right? So I'm just going to say in this problem, our goal, and I'm going to phrase it as goal, is to determine if the state birth rates for men, or for women, for women ages 15 to 17 seem to be different in 1990 as compared to 2016. Okay, so state done, 1 out of 4 done. This isn't so bad, right? Okay, so now I'm going to do the plan. This is where, again, I'm saying the tools, methods, assumptions, and any variables. Okay, so let's take a stab at that. Okay, and I paused the video and wrote down my answer. Well, there's a few typos in there, but you understand. So, so I said to answer this problem, we will use the state rate data for births, and that's a quantitative continuous variable. So I actually started with identifying the variable and its type, and then I said, okay, this is what we're going to do. So I'm stating the tools and methods. So calculate descriptive statistics, visualize the data using histograms and box plots. Okay, and then the last step is checking my assumptions, and the assumptions are, okay, well, if I'm making all these things, I need to make sure I have a quantitative variable, and that is true because the data is quantitative continuous. So I just wanted to make sure to address that assumption. So I formulated it different than how I have it listed in the 4 steps, but as long as you have all the pieces, we're solid. Okay, all right, so then solve. I'm just going to say for this part, see the region to the right for the data and charts. And I'm going to do everything that I said I was going to do. So I'm going to do descriptive statistics for both, 1990 and 2016, and then make histograms and box plots for both. Okay, so I'm going to encourage you to pause the video, try it on your own, and resume the video when you're ready to see the answer. And so I did that, and I made the histogram. I made it all pretty. It didn't specify any particular bin, so I just left it kind of as the default. Okay, did the same for 2016, got the descriptive statistics for the two things. Okay, and then there was one more thing I was going to do, which is the box plot, and I was able to do both of these in the same year, or in the same plot. Okay, so I think I did everything that I needed to do and that I said I was going to do in the plan step, right? So let's see. Calculate descriptive statistics, visualize the data using histograms and box plots. I did everything. Okay, so now I'm going to conclude. And so this is where I want to respond to the question. So if the state birth rates are different in 1990 as compared to 2016, and then I need to, conclude in context. So I want you to actually, I'll share with you what I originally wrote. Okay, so here we go. So it says, in examining the descriptive statistics, the means are different. So I'm talking about the data that I produced, right? So I'm using the descriptive statistics saying the means are different, right? 35 as compared to 8. And then I'm talking through next the box plot, right? The box plot shows that the 5-number summary in 2016 is much lower as compared to 1990. Okay, and then when I look at the histograms, they kind of have the same shape, kind of a skewed to the right distribution. Symmetric if you want to go that far, maybe a little bit in the first one. But they are significantly different. In fact, like this one starts at 15 and this one nearly ends at 15. Okay, so then I'm going to say because of this evidence, right, now I'm concluding in context, this suggests that the birth rates seem to be different. Okay, the only thing that I didn't do here is discuss sources of error. So I could add on here and say the only source of error is from misreporting the data. Okay, we on our end with the statistics didn't do anything incorrectly because we haven't done anything with probability. So we just have to acknowledge that there could be some error from the data that we were given was faulty to begin with. So we should do that. Other than that, this is our 4-step method problem, and it is lengthy. Okay, so just be ready to kind of do this and spend a little bit of time on it. Okay, so you'll see this over and over and over again in the course.